All right, a couple more examples about projectiles. We have a baseball that's launched straight upward with a velocity of 12.4 meters per second and is caught at the same height from which it was thrown. All right, so we're going to list the information we know. First off, we know the horizontal and vertical direction. We know the acceleration. Acceleration in the horizontal direction is 0, and then the vertical direction is going to be negative 9.8 meters per second squared. All right, the other thing we know is that we have a horizontal velocity of 0 because it's thrown straight upward into the air, meaning that we have no initial velocity in the x direction. The y direction, it's thrown straight upward, so that means the initial velocity in the y direction. The upward direction is going to be 12.4 meters per second. All right, so how long does it take to go up and come back down? So a new piece of information we have here is that the displacement is going to be equal to 0. Now keep in mind that when it goes up and comes back down, how long, how much time it takes depends completely on the vertical direction and has nothing to do with the horizontal. So we're going to use the vertical information here. All right, so we got the acceleration, the initial velocity, and the one extra piece of information, since it came to the same height from which it was thrown at, and that means it's going to have a total displacement of 0. All right, so the acceleration, the initial velocity, the displacement, we're looking for time. All right, and that's going to give us the displacement is going to be equal to 1/2 times acceleration times time squared plus the initial velocity times time. Plug in our numbers. All right, displacement is going to be 0. That equals 1/2 of negative 9.8 times time squared plus the initial velocity in the y direction, which is 12.4 times time. All right, so clean this up a little bit. We get 0 is going to be equal to half of negative 9.8, so negative 4.9 t squared plus 12.4 t. Okay, so the one thing that I usually do at this point is I would take one of these common terms of t out of both of these and take that to the other side. Some people don't do that. What they would actually prefer to do is take these two terms. We got one term that's being added to another and take one over to the other side. So taking this negative term over to the other side becomes positive, so 4.9. And don't forget to take that variable with it because it's attached to it, being multiplied by t squared. Then that's going to be equal to what's left on the other side, which is 12.4 t. Next thing to do is to notice that you have a common term between these two. You have t squared, so you got two t's over here being multiplied together, and then you got one t over here being multiplied by the 12.4. So that means we can divide both sides by one of those t's. So it cancels from this side. When we divide this side by t, it cancels one of those. And I'm left with 4.9 t equals 12.4. All right, so one of those t's cancels, leaves one behind. This t is completely canceled, just leaving the 12.4. Now we divide both sides by 4.9, 4.9, and we get that t is going to be equal to 12.4 divided by 4.9, and we get 2.53 seconds for our hang time. All right, the second part says, how high will the ball go? We're looking for the max height. Now, in looking for the max height, you're looking in the vertical direction. Now, you got to keep something in mind here. This vertical direction is our unknown. That's not the same as the vertical displacement up here. The vertical displacement down here is when it goes up and goes to the very top, how high it is. This one up here, B, refers to going up and coming back down. So this displacement for part B is 0, but for going from the bottom to the top, that displacement is unknown. All right, we still have the same information we need in the vertical direction. We got the acceleration in the vertical direction. We got the velocity in the vertical direction. So the question is, what do we know? What do we know about the max height? Now, something you could notice, and you would get the right answer doing this, but if you took the time and divided by 2, you could use that time to get to the top. Now that's one thing you could do. It doesn't work every time. It only works because we're dealing with a symmetrical problem here. But what does work every time is that the final velocity when you get to the top is 0. The reason for that is because as it goes up, it loses 9.8 meters per second every second. So as it goes to the top, it loses all of its speed. It goes to 0 before coming back down. All right, so that means we're going to use the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. All right, so final velocity is going to be 0 squared equals the initial velocity, which is 12.4 squared plus 2 times negative 9.8 times displacement. Okay, so running out of room here, I got 0 equals 12.4 squared. 12.4 squared is going to be 153.76. All right, so separate problem here. And then that's going to be plus a negative 19.6 times the displacement. All right, now bring this 153.7, we bring that to the other side. So I'm going to actually come over here. Take that 153.76 to the other side. It becomes negative. And then that's going to be equal to what's left on this side, and that's negative 19.6 times the displacement. Now keep something in mind. Don't take these two numbers and subtract them, because this one's being attached to that displacement right there. So it's attached to a variable. So we cannot subtract those two. So the way to isolate is to take this number to the other side, becomes negative, and then you have negative 19.6 times the displacement on this side. So we divide both sides by negative 19.6. And then that leaves me with my displacement is equal to negative 153.76 divided by negative 19.6, and we get 7.84 meters for our max height. All right, next problem. Number 2, it says a rock is thrown horizontally off of a cliff with a velocity of 27.1 meters per second from 41 meters above the ground at the base of the cliff. All right, so we're dealing with a scenario where we're up here, and it says it's thrown horizontally. And then as it's thrown horizontally, it falls down to the ground. All right, so what do we know horizontally? Well, we know vertically. First of all, we know the acceleration. All right, the horizontal acceleration is always 0. The vertical acceleration is always negative 9.8 meters per second squared. All right, so 0 for the x direction, negative 9.8 meters per second squared for the y direction. For the initial velocity horizontally and the initial velocity vertically. All right, so the initial velocity in the horizontal direction and the vertical direction. This is one of those key things you need to know about projectiles, is that the horizontal and the vertical are independent of each other. They are separate, and the initial velocity given right here, that is the horizontal velocity. And if that's the horizontal velocity, then that means this 27.1 meters per second is completely in the x direction. All right, and you can see that with horizontally. Well, if it's completely horizontal, then what does that mean about the vertical? What does that mean about the vertical? If it's all horizontal, there's nothing that's vertical, so it's 0 in the y direction. 0 in the y direction. All right, so next thing we know is that it is 41 meters above the ground. All right, so that's this direction. 41 meters. So if it's 41 meters above, that's a y direction. So the displacement in the y direction is 41 meters. But you have to be careful with that, because we're starting up here and we're ending down here. So we're actually going downward, and a downward displacement means you need to include that negative.